What's up YouTube? I'm back again with another video on this old Teac A-6010S. The original video I made on this thing actually got taken down and deleted by YouTube themselves, I think for a copyright strike or a match. I definitely can't continue doing that. This is a very old unit anyway. It's the first sort of version was the S model, so it could be anywhere from the late 60s all the way up to maybe 1970 or 71 at the latest. Cosmetically, this thing's fairly clean. Now I've got my screwdrivers here. These are good screwdrivers with a nice rubber grip. And then I actually use my tape head demagnetizer to demagnetize these because you don't want magnetized tools near any sort of tape machines or tape path. And then I have the little block magnetizer demagnetizer thing where you just stick the screwdriver in and wave it around, but I think these were magnetized so strongly that those didn't have any effect, so I literally just use the tape head demagnetizer and it seems to work. I first want to look at this amp. I found some service manuals on Hi-Fi Engine. So the model number of this amp is the AR60, which is actually used on both the 6010 and the 7010S models. So I went on Hi-Fi Engine, searched for this A6010, and I didn't really see that the service manual had any PCB layout shown. So then I looked for the service manual for the A7010, and then that actually had the board layout with the view of the components from the foil side with all the traces marked where the components are. So that should be the same since this is the same record preamplifier. I'm going to reference that for even attempting to do a recap. So in the past I've owned a couple different A4010S models. Again, this is the 6010. So to get this amp out, it looks like there's a series of screws around the cabinet. Like possibly these two bottom ones on each side, and then it looks like there's also screws on the underside of the cabinet near these rear feet, like there and there. And this is a rather heavy unit and I don't want it tipping over or anything. It probably weighs close to 60 pounds. So I'm going to try to take these screws out off camera and see if the amp will slide out. Well, it took a little bit of persuasion to get this thing to want to come out, but it's free. It's probably because there's a little bit of rust forming here, so this may have been in somewhat of a damp environment. And then with a lot of these record preamps, there's usually the RF shielding sort of metal covers surrounding the whole thing, just to cut down on any RF interference, I guess. And then I want to grab some mini Ziploc bags to try to keep these screws safe so they don't get lost. But that's why I really like some of these particular models of Teacs where these amps are just removable and then you don't have to have the entire enormously heavy deck in front of you. You can just work on the amp separately, which is nice. Okay, here's a look at the internals. This is actually the underside. The components are all face down, which seems unusual. And then this is the thing right side up, which is the foil side. And there's actually a lot of hardwired wires in here, so that might make this a bit challenging to work on, to say the least, especially with trying to get the soldering iron or my desoldering gun in and out of here without messing up any of these wires and stuff like that. That's definitely going to be a little nerve-wracking. But anyway, it's kind of also interesting that the existing caps in here appear to be Matsushita Electric Industrial Company caps because I recognize that symbol straight away. They use these Matsushita branded caps in a lot of older Panasonic equipment from the 70s. And I've had some 4010S Teac models with, I think a lot of those have had really old Elna caps in them. But this is the first I've ever seen Matsushita caps in some old Teac equipment. And I also want to bring up the page I printed out with the foil side of this amp board from the 7010, or I can pull it up on my computer from Hi-Fi Engine. Alright, I noticed a couple more things, at least on these 6010S models. The screws for these real tables are literally plastic, and the heads always snap off and break a lot on these, but at least a couple on the take-up side have already broken. I'm not sure if these supply reel side ones are still intact. They don't feel broken, but that doesn't mean they won't break if I try taking those out. Anyway, here's just one of the pages from the 7010S service manual, which I recommend looking at if you're servicing a 6010. So all the wiring in here is outlined on this diagram, which is definitely good to have, because just the insulation alone on all the wiring in here feels really crusty and old, so I'm like nervous about having to disturb any of the wires in here. And if anything should break, or if I end up needing to desolder any of these wires to work in these areas to get at the caps, then I can refer to this and hopefully put everything back in the right spot. Because there's nothing worse than something breaking or coming apart and you don't know where to put it back. And then the other side of this page I printed out is the board layout on this foil side, which is the same top view side here. And this just outlines all the pads as far as where the components are. And I saw the parts list for the preamplifier in that service manual, but for whatever reason it only appears to outline the semiconductors, which is just all the transistors and diodes pretty much. Yeah, anyway, these are all Matsushita caps, and they're kind of notorious for breaking down and failing, or even sometimes they can bulge and explode. A lot of YouTube community people say when you have old Panasonic equipment with these caps that you should just get rid of them and replace them ASAP. So I guess that's what I may have to do with this. Now there's one rather important thing to note about some early Teac models, such as this one, is that they use PNP germanium transistors a lot of the time, which means there's a positive ground. So it's kind of a reverse polarity sort of application. And particularly when you look at the radial lead electrolytic capacitors, the stripes are all marked positive. So when you go to replace any of these capacitors, you want to make sure the polarity is correct for that reason. So the polarity is accurate in this layout drawing. So you don't want to just pull these out and match up the stripes on the replacement modern caps. Because obviously on modern electrolytic capacitors, it's the negative side that's marked with the stripe. The last thing you want to do is to just shotgun the whole thing at once and then find out something's no longer working, and then it makes it that much more impossible to actually troubleshoot where you went wrong. In most cases, there's portions of the circuit board that could be a mirror image from one side to the other, and that's because One part will be for the left channel, the other part will be for the right channel. There's usually like bias, trap adjustments, and also equalization, so on and so forth. This section here is for your oscillator. This is the oscillator itself. And then there's usually relays in a lot of these boards. So I think some of these relays are typically for engaging the record mode, because it's all electromechanical with relays and solenoids pretty much. There's a chance that I might have to desolder some of these wires just to give myself enough working space to get the irons in and out. So this is definitely nice to have. And also, one other difficult thing about the old Teac equipment is just trying to pull the old caps out. It's rather difficult not to damage some of these pads or even lift traces, because a lot of the times they like to bend the leads completely flat and over top of the traces, as I'm sure you can see here. But yeah, that makes it more difficult to remove some of these because there's a lot of solder just over top of the actual traces to secure them down. So that makes it really difficult when you're trying to desolder and pull stuff out. And then it gets to be a real mess when the traces do lift and you have to put a bunch of jumpers in here and stuff like that. So I'm not a huge fan of all this or working on this. I mean, it's well made, but it's just a lot easier to work on a more modern printed circuit board as opposed to this just being more primitive. Just for my own documentation's sake, I've labeled these shielding covers for the amp. I denoted this as the lower one that goes on the underside here, and then the front part just goes toward the front, which is facing toward the front face. And I've done the same for the upper one. I just want to make sure these go on the same way they came off and with the correct orientation. And then I've got these Ziploc bags with all the screws. So all these screws are the same. So I've combined all these into one bag. So these go with these shielding plates. And then I've put all 6 of the screws and the little washer things in this other bag, and those go through the cabinet to secure the entire amp module into the cabinet. Now I just want to write down all the different capacitance values, so if there's anything I don't already have on hand, I can just order replacements for. So I guess I may as well start on this side and work our way across. So in this bias oscillator section, we've got what? 220 microfarad, 25 volts. This, I don't know if it matters what section. We'll just put oscillator. Alright, then we got these 3 axial lead caps. I don't know if these are part of the power supply, I guess. So we got 1000 microfarads. These 2 are 25 volts. This one's actually 35 volts. So I guess I may as well just get all 35 volts or more. So let's see, we'll write radio. So we've got the 3 1000 microfarad. Axial, well, 35 volts we'll say, and then axial. So that takes care of that. And then moving this way, some of these small caps at least in the 4010 models, and probably this one too, are usually rated for 6.3 volts, and they can be 47 and 10 microfarads a lot of the time. It's hard to even see a lot of these. 25 volts, 100 microfarads, 33, 6.3 volts. So let's write these next biggest, or we just go big to small, which might be easier. And then I guess I'll just make it implied that the rest of the caps are all radial from this whole section onward in the amp. Also, sometimes you might see these radial lead caps that are a different color, like these yellow ones in here. And in some cases, they're either just a different value, or they could possibly be bipolar capacitors. This one looks like it's got some polarity marked as positive right there. So it doesn't appear to be a bipolar cap, but it's something different. It's different in some way from the rest of them. I don't know exactly why that's done. If it's for, I don't know, some thermal properties or impedance or something else, but I've seen that in some cases too. Alright, so I got my list. I think that's most of them, if not everything. But already it looks like some of these caps are definitely starting to bulge. So it's, good we're trying to catch this in time before anything actually explodes. But yeah, these axial lead ones definitely look like they're bulging, especially this one. And even a couple of the small ones kind of look like they're bulging. As far as any actual date codes, you usually have to go by the motor run caps. I forgot what else I intended to say, but I ordered the caps yesterday, I think, from DigiKey, so I got 20 of each just to have a bit of a stash on hand. And then I was also looking at some online forums regarding the plastic screws used for these reel tables, and it says not to use metal screws, which I think is something to do with the magnetization, and I think there was one other reason too. I'm drawing a blank. But anyhow, hopefully I can find equivalent sort of replacements for these. Maybe I can find replacement screws for those. And then I'm also wondering any of these that are still intact, if they'll come out without breaking. So I can maybe just get the full length screw out of here and see how long one of these would be. And then I can have a better idea of the proper replacement. So I think this is the entire non-broken screw. So I'll probably just measure that and see what I can find out there. But it's a pan head screw, and then online when I was trying to search for some replacements, I saw like a slotted flathead screw that was just white nylon or something. But yeah, hopefully there are suitable replacements for that, because I've read that you don't want to use metal. But yeah, I'm a little worried about how to extract these broken screws though. I've heard of some people using drill bits and stuff, and I don't entirely feel comfortable doing that because I wouldn't want to mess up the threads inside. Because yeah, I'm going to need to get those out, and then I'm probably going to want to get the faceplate off at some point to just lubricate everything, because I think this arm here was a little gummy, so that might need some lubrication so it can properly put the right tension on the tape and then move quickly when the tape stops instead of being all sluggish and bound up like it is currently. So first I think I'm just going to primarily focus on the amp and then worry about the rest of it after this is all done with. So if I do actually need to desolder some of the wiring to be able to get in here with my soldering iron, or let alone my desoldering gun, those are all labeled on here with the wire colors and what pads they are soldered down to. But then I also have some of these, and I kind of recommend them just to keep everything straight and more organized. And then I'm pretty sure I got this little booklet on Amazon, but it's made by Klein Tools, and then it's got even and odd numbers, and you can just use these to index all the wires you take off, which I think is helpful. Actually, I think one of the things mentioned in an online forum was that you could just take a screwdriver and put it in here and apply heat to the screwdriver, maybe with a soldering iron, and then the heat of the soldering iron could maybe just melt the entire screw, or possibly melt a new head into the broken section, and you could loosen it that way. But I do remember reading that, so I might have to just give that method a try. But seemingly it appears that only, I think just these two were broken out of the 6. Yeah, this is very different construction than I've ever seen before. So the supply reel side just had this plastic spacer in here too, so that's probably another reason why the screws are plastic. The take-up reel side had the plastic spacer and this thin metal spacer here. But yeah, it's definitely different how the entire shaft is part of the reel tables. I haven't seen that before on my other Teac models. It's always been on this part. And I almost think I saw some videos where there were springs on this part in here, but I'm not seeing any kind of springs present on this, so I don't know if it was previously taken apart and worked on at some point, or what the deal is with that. But I feel like, at least in somebody's video, I thought there were springs here behind the reel tables. But anyway, I seem to have gotten the rest of these plastic screws out all fully intact. So I'm just going to double check the length and see if I can try to find any replacements. Because even though these haven't broken yet, they're still old and they could get brittle over time and eventually break. So anyway, I think that pretty much is going to wrap it up for this video. So this is kind of part 1, I guess. I'm going to see what I have and order anything I might need, and then we'll go from there and make a future video. So yeah, I'm definitely a little frustrated with these plastic screws, and then the pinch roller is kind of glazed over, so maybe I can condition this with rubber renew. And yeah, we'll see how far we get. So anyway, like, comment, and subscribe, and stay tuned for future videos on other projects, as well as continuing on this. So thanks for watching, and goodbye for now.